So for this one here, I want to know what is the limit as n goes to infinity of 1 plus 5 over n to the power n. Not a bad idea to look at it graphically. So here I'll call it f of x equals 1 plus, again, 5 over n. To the power n. X, sorry. There we go. All right, so zooming out on the function, it looks like it might settle down after a bunch of terms. We just need to figure out where it's going to settle down. The problem with this one right here is that we have n in the base and we have n in the power. But we believe that there's a limit based on the graph. Let's call that limit L for a second. How do we get a number out of a power, or a variable out of a power? There's two options. We could use the nth root, or we could use a logarithm. I'm going to use a logarithm. That's the approach we took way back in Calc 1. So what I'm going to do here is I'm going to take the natural logarithm of both sides. Cleaning up this side right here, if a limit exists, then the function of the limit is the same as the limit of the function, if that function is continuous. Natural log is continuous. So I can rewrite this as the limit of the natural log of 1 plus 5 over n to the power n. And then I can pop that n out of the logarithm. So then I get the limit as n increases of n times the natural log of 1 plus 5 over n. And I'm going to apply one more trick to this right now, because here's the problem I have at the moment. As n goes to infinity, what's happening outside? Well, as n gets large, n gets large. But what's happening in here as n gets large? 5 over n is getting smaller. 1 plus 5 over n is going to 1. So this is going to 1. What's the natural log of 1? 0. What's 0 times infinity? Well, it depends. Is it going to 0 faster than it's going to infinity, or is it going to infinity faster than it's going to 0, right? Who is winning that battle? I don't know. Who can help us figure that out? L'Hopital. But L'Hopital has to be a fraction, like 0 over 0 or infinity over infinity. So the trick on this then is to rewrite this times n to instead be a divide by 1 over n. Right? Dividing by 1 over n is the same thing as multiplying by n, right? Multiply by the reciprocal idea. Now, if we think about this limit as n goes to infinity, the numerator is going to 0 and the denominator is going to 0. So I can't apply L'Hopital's rule to this. So according to L'Hopital's rule on this one right here, derivative of the numerator. Okay, we got some serious calculus to do. We're taking derivatives, which have an extra equal sign there. Derivative of the natural log is what? 1 over whatever's inside. So we're going to have a 1 over 1 plus 5 over n. But the chain rule says I have to multiply that by the derivative of 5 over n. Okay, what's the derivative of 5 over n? Well, 5 over, that's supposed to be a 5. 5 over n can be written as 5 times n to the negative 1. And the derivative of that is going to be what?
Negative 5n to the negative 2nd.
Yeah. You bring down that power, reduce the power by 1. Okay, so I'm going to have a negative 5n to the negative 2. Divide, what's the derivative of 1 over n? Well, that's like this, but without the 5. It would just be negative n to the negative 2. We're still taking the limit of this as n goes to infinity, but things clean up a little bit. The n to the negative 2 here and here is going to divide out. A negative divided by a negative is a positive. And I'm left with now the limit as n goes to infinity of 1 over 1 plus 5 over n times 5. Can we evaluate this limit using some tricks we know? I think we can. What's happening to this as n gets big?
Smaller.
It's getting smaller to 0, right? So that part right there goes to 0. 0 plus 1 is 1. So in the limit, this is 1 over 1 times 5, which is 5. What's 5? Well, if we go all the way back out to the top, the natural log of our limit is 5, is where we're at now. Natural log of L is 5. What base is the natural log based on? E. So this is another way of saying e to the 5 has to be L. Let's check if that matches the graph we just worked with. Back on the graph, if I just graph y equals e raised to the 5th power, that looks like a horizontal asymptote for this function. I think we did okay on that. So when you have a variable in the base and the exponent, you have to use a logarithm to evaluate the limit.